I have to give it a couple seconds. Okay, so let's get to the outline, and I'll go over what we're going to do today. So this first one's the first one, I'm just going to really briefly go over a change I made to the factory contract, and I'm not going to spend much time on it because I'm not even pushing this change through, and it's really the only reason I'm doing this is to help with David's seminar tomorrow. So I'll do that quite quickly. Next I'll go over the bug that I ended with last seminar and the fix, and then show that feature that we were trying to build actually works, and that's quite exciting because that makes the whole interface we're building here much more complete. Then we're going to add deposit and withdraw buttons. That should be actually quite trivial. Then we're going to modify the interface to allow the user to view billing permissions. So we have the interface to set billing permissions, but we don't have any way to view it, so we're just going to add that in. And we're also going to make that well, it'll work with any user. You won't have to be the owner. You could be the user, the biller, or somebody completely doesn't even have a role in the contract. You'll still be able to view the billing permissions. If you give it an address, you can view that. Then we're going to, let's see here, we're going to, the set billing rate interface, part of the interface, we're going to make that only visible if the MetaMask is set to the address of the owner. And then we're going to add in a button for the biller to use where they can click it and it'll pay them whatever they're owed from the contract. And I do think we can actually get through all of that today, and if that's true, then we'll actually end up with a pretty complete proof of concept of our interface here. And I should go just load that up here. So yeah, we should have this thing sort of complete by the end of today's stream. So that's pretty cool. A note, by the way, on proof of concept. I'm always talking about proof of concept, and there's another one that I throw around also called MVP. So there's POC or proof of concept, and there's MVP, which is minimum viable product. A proof of concept, and I think I mentioned it somewhere in here, but a proof of concept is a stage in development that I think is pretty important when you're talking about smart contracts, and it's when you can you have something that's complete enough to where you can sort of imagine giving it to a friend. Maybe you have to explain how it all works, but if you can explain to someone how it works and how to use it, then they can go and use it, and it's they can see a glimmer of utility there. So it's the proof of concept, it's the proof of some sort of glimmer of utility. And that's what we're going to be going for in general on Wednesdays. And then there's another stage after that called the MVP, or minimum viable product, and that's when you can actually hand it to a user and maybe hopefully not explain anything, and they'll still find some utility in it. So anyway, we'll be focusing on the proof of concept first. And so as I go through developing these, you'll see me sort of throwing out features left and right and sort of saying, I'm not going to worry about that, not going to worry about this, and that is often in pursuit of the proof of concept. I mean, obviously this could be much prettier, but the proof of concept does not need to be pretty, and so I'm just not worrying about it. Okay, so let's get on to the first one here. So all I've really done is I've added an array here to the factory contract that stores addresses. And then whenever there's a new subscription manager, you just add that address to this array here. Pretty simple. And now because this is public, there will be an automatically generated getter. And I don't want to get too into the deep motivations, but I did the same thing with Toasty Coin, and it just lets an interface be able to kind of iterate over everything that this factory has created, which sort of by definition is every single subscription manager, or at least everyone that came from this manager factory, which is good enough. And then so tomorrow David will use the fact that this exists and it has all of these addresses in it to to iterate through these in a more automated fashion. I'm pretty excited for his seminar. That'll be cool. Okay, I think that's all I need to say on that, and we might talk a little bit more about, well, we'll demonstrate why this is useful in tomorrow's seminar. And okay, so that's number one. Let's cross that out. Okay, now briefly go over the bug we ended with last seminar. Okay, let me get the code up here, and here, let's see. Oh yeah, here it is right here. So this is the line we were having issues with, and whenever we called it, we would get this bug saying that that something was not a number. And I sort of wish I had a screenshot or something to show you live, but you can go back on the last video if you want and look at it. The post for the last video, so on the blog, it'll point out the specific timestamp that I introduced the bug at, so you can go look at it if you want. But what I had, I guess I could just copy this line here, put it in, and I'll just show you what I used to have. So this is what I used to have, and this empty dictionary is a transaction object. It tells the Web3 call how much gas you want to put in, or what account to send from, etc. This is also where you tell it how much ether to send with the function call if you want to. But this line here, it's out of order. This should not be the first argument. And I was confused because when you call a contract function like this and you don't have arguments to pass to the contract, then it will be the first. I mean, it'll be the first. This is supposed to be the first argument after the contract arguments. So if there are no contract arguments, that means it's the first one. So I got in the habit of putting it there at the beginning, but that's incorrect. It doesn't go there. It actually goes right here, like this. Okay, so that's one change, and that actually fixed the bug. Well, it fixed one bug, and then we had another bug saying that the gas was not high enough. And so then instead of putting in an empty array, or sorry, an empty dictionary, I'm just going to erase this line. I actually define the object up here, transaction object, and I say that the gas and the gas price. Again, there's a few more options I could have put in here if I wanted, but then I pass that here. And so that those two steps allowed this whole thing to work. And if you go to the seminar source code repository, I have the commits showing those changes. So you can actually replay those changes if you go back and look at the commit history of week 2 on this file, subscription manager interface .html. So, okay, that's the bug. Now let's demonstrate the feature. So I'm going to go here, and here's my here it is, all loaded up, all ready for us. Now, if you'll recall, we can create a new subscription manager. I guess I might as well just do that. We'll just demonstrate the whole sort of cycle of this tool here. First, I should make sure I'm logged into MetaMask, and make sure I'm on Ropsten, which is good. And now that I've changed my login info here, again, I'm going to refresh the web page. It's always a good idea to do that. Okay, it's loading my user address, and that all looks great. And let's click this now. And give it a second. Okay. And confirm. Okay, so now we can see that the create SM contract transaction, it gives us a transaction ID here. We can take this, put it in Etherscan, and look at it, but we can do the same thing basically by clicking on here in MetaMask. It brings us to the same transaction. So we'll wait for this to load. Usually does not take long on Ropsten. When it loads, we're going to go look at the internal transaction and get the address of the new contract that's created, and we'll use that address in the rest of this interface here to demonstrate this new feature. Once it loads, there it goes. Okay, so I'm going to go to internal transactions again. As I said last time, it can be a little bit confusing. There's a contract here, so it might mislead you into thinking, oh, that's the contract address. It's not actually the contract address. This is the transaction going from my MetaMask, that's my MetaMask address, to the factory contract. That's the factory contract right there. So I want to go to internal transactions, which will go into more detail about sort of all of the, you could say, byproducts of the transaction. And now we see there's a create And here, I think this is the symbol, yeah, new contract created. So we click there. There is our new contract, our new subscription contract. So I'm going to copy the address now, go here to our interface, put it in here, and there we go. That's great. Automatically generates a lot of stuff. It grabs the owner from that automatically, which should be my whatever I was logged into in MetaMask. Let's see who I was. I was main, ends in F964, and indeed that ends in F964. So that's great. And this just generates the QR code as we showed last seminar. So now here's the bit that was not working last time. It should be working now. It worked when I fixed the bug yesterday, so hopefully it still works today. So we want to set biller permissions. Okay. I am going to get a biller address. I'm going to grab that from a different MetaMask account here. Here, go to Test Alice, load Test Alice, and go back to main, or copy Test Alice, I should say. And I'm actually going to, once again, open up a text file and just save some of this. This can be really helpful just for development purposes. I'm also going to take this. While you're developing these smart contract stuff, you can be dealing with so many transaction IDs and addresses. It's really helpful to just keep some notes as to this way, if I lose all these tabs or I close stuff, I can still quickly find the information I need to without having to go through MetaMask. And while I'm at it, I'm just going to go back to MetaMask again and copy my main address, which is also right now the owner of the contract. So do that, and maybe say this is all MetaMask. And then just to make it a little bit clearer, owner and biller. Okay, so of course Alice is not a biller yet. We still have to set her permissions to make her a biller, but we have her address now, so we can take that, put it in here, and now approved billing rate, ETH per 30 days. We're going to do 0.01, set permissions. MetaMask pops up. That's good. That's all. We're already past the bug we had last time. I'm going to now confirm, and we have now another transaction broadcasted, set bill rate transaction. Again, I can grab that from there, put it into the Ropsten Etherscan, but I'm just gonna, it's always a little bit easier to go here and click here. Oh, look at that, already confirmed. Just before I clicked that, it said confirmed. Okay, so that's good. Now one thing we don't have in this interface yet is a way to view biller permissions, and we're going to get to that soon, but first I want to just demonstrate that this did affect the smart contract. So to do that, I'm going to go to another tool. I'm going to use MyCrypto. This is my MyCrypto / MyEtherWallet. I used to use MyEtherWallet, now I use MyCrypto, but they're very similar tools, and these are my go-to tools if I want to interact with a smart contract that there is no interface built for yet, or if I want to see something about it that there's no interface to tell me whatever I'm looking for. So you go to contracts, and I've shown this a couple times on the stream, so this won't be anything new to you guys, so I probably don't really need to talk through it. I need to get the contract address, which fortunately I just put here. And I need to get the ABI, which should be in our, not in the stream, in the file. Right at the bottom of this. Come on now. Yeah, all this. SM ABI. Make sure you're getting the right ABI, because we're dealing with two contracts now, the factory and the subscription manager itself. Each of them has their own ABI. So you want to make sure you're grabbing the right one. Oh, I don't need that there. Okay, copy and paste and access, and now we have access to all those functions. Okay, so what I want to do is go to billers, and I want to put in Alice's address and make sure that it gives us what it should. It should give us, of course, it's going to give us the value in way, so it's going to be a bizarre number, but let's read it. No, oh, I need to go to Ropsten. I always make that mistake here. Ropsten. Okay, now I bet if I click read, there we go. It's all correct. So let's look at these values. Let's just make sure that they're what they should be. So the easiest one is going to be last bill time. Also, these weird numbers that are coming back, they're so unreadable for humans. That is the real power of an interface to these contracts. You can use these general tools, but they just aren't intelligent enough to know that, for example, this is a time, so it should output it as a date. So now we got to go here, we got to copy that. Well, actually what I usually do is I just go to Unix timestamp, whatever that website is. It's maybe something I should have bookmarked. But this outputs the timestamp, and then we can just compare that to the number. So the last 5 is 28141, and let's go here 27962. So that seems about right. That went on a few seconds before what the time it is that I loaded this page, so that's fine. Now the rate. Now remember the rate. If we go back and look at the remix, or sorry, the Solidity. The biller rate is way per second, and that's how we've been programming this. That's how our interface, when we put in a number here, our interface takes this number and converts it to way per second before submitting it to the smart contract. And which again, that code is, let's find that code again just to look at it one more time. Set bill rate, here's our 3 lines where we actually do those conversions. And so what I want to do now is sort of independently take this number and make sure that that is the rate that we want it to be, because this math here, we might have messed that up. So that is the next step. I want to take that and figure out how much ETH per month that ends up being. First, I think I got a notification on Slack, Dev General. I'm going to ignore that. If that was you and you have a question about Slack, the seminar, please post it in the seminar chat. It helps me organize and not get off track. Okay, so yeah, so I need to take this number here, and I guess I want to take a calculator. Well, first I want to, okay, this is way per second. Let's convert that into ETH per second. I guess I'm going to do some thinking out loud here on this. We have way per second. Convert to ETH per second. Okay, so that's going to be just as easy as using an Ether unit converter. Go there. We don't need that timestamp tab open anymore. Let's get the rate, copy it, paste it into the way, and then here is the Ether value. Okay, so we have that. Let's go ahead and put that in our text file. So we have this ETH per second. Now we just need to translate that ETH per second to ETH per month. And so I always have to think a little bit here. That is going to be, we need to multiply that by a few numbers. So let's get the calculator up. So if we have this per second, we need that's going to be per minute, that's going to be per hour, that's going to be per day, and that's going to be per 30 days. So now this should work out to be 0.01 roughly. Hey, that's great. Look at that. Perfect. Cool. So that's good. That verifies everything works as it should. So just to recap, now we have this this interface here, which we could just as easily upload to GitHub Pages, and we'll probably do that on Friday. Actually, get it up public so anybody can use this. Of course, anybody can fork this and make it GitHub Pages on their own if they want. Nothing wrong with that. But any interface that uses this and uses the same factory address will see the same. Well, they'll be able to make the subscription contracts by clicking here. Then you can get the address from that, put it in here, and you can set builder permissions. And that's what our interface does right now. And we've just gone and verified through an independent interface that it actually is setting those correctly. So that's all great. Now the next thing that we want to do, well, first let me go back to my outline here, because that is now done. Strike through. Okay. All right, item 3. We're chugging right along here. Only 20 minutes in. That's good. Add deposit and withdraw buttons. Let me just get some water here. Okay, so I guess let's just throw the buttons in there first, right away, and then we'll get the functionality going after that. Okay, well first, what do we want these? Let me go back to my interface. If it's set biller permissions, it'd be cool if I just feel like it should write maybe, well, the deposit button should go right next to this QR code, or right near it somewhere. Maybe right after this QR code we could have a little button. Sure, okay. So let's find that QR code. It's under subscription interaction. There's our QR. Okay. Now let's go button. And what's the text of this button going to be? Just deposit. I guess that's pretty basic, huh? And we're going to make the on-click equal to a function called, what do we want this function to call? I guess just deposit, call deposit. Well, remember there's no deposit function in the contract. This button should really just trigger a regular Ether transaction to the contract address. So our JavaScript function name, just to be a little clearer as to what's actually happening, should probably be something that reflects that reality. So maybe like send, let's see. I'm struggling for what to name it because I want, when we call this function, the function is going to have to also ask the user how much they want to send. So I'm just going to call it trigger send ether to SM contract. It's a bit of a mouthful. Maybe I'll change that later, but that's good enough for now. Okay, and then for withdraw, I think I'm going to put that under the owner here, because we want this withdraw button to, later we're going to make it to where this button will disappear if you are not signed in as the owner. And maybe we could even add something here that says you are the owner. I'm just going to put that as a bonus, little bonus bit on our yeah, bonus output whether user is the owner. So our interface is going to have to know whether the user is the owner, because it's going to hide number 5 here. We're going to hide part of the interface if they're not the owner, but as a quick bonus, we can maybe actually output that to make it clear when you're using this whether you are the owner or not. Anyway, okay, let's get back to our code here. Yep, here we're going to do another button. On click equals, whoops, trigger withdraw. And actually, well, yeah, just do trigger withdraw. Okay, that should be both the buttons. Let's just refresh and make sure that looks okay before getting into the functionality. Oh, I have to put in the address again. Okay, contract. Okay, we have a deposit and a withdraw. I wish that deposit was closer to this QR code. I guess I can just visually separate it really quick. I'm just going to add another break right there, and maybe that's just enough for me. Yeah, that's fine. That's enough. Okay, now let's define these functions here. I'm going to copy this because it's a long name. Which one should we do first? The deposit or the withdraw? Let's do the withdraw first, because that's just calling a contract function like we've done before. This one's going to be a little bit different. Might even be simpler, but let's go with this one first because we've done more stuff that's like that. I am going to put it, I suppose, before call set bill rate. And what is it? Trigger withdraw. Yes. Okay. So this function needs to do two things. It needs to ask the user how much to withdraw and how much they want to withdraw, rather, and then how and then actually call the Web3 function. So let's this is super hacky to do what I'm going to do here, but I'm just going to do the JavaScript prompt function, which it's just a pop-up and it just lets you put in a number. It's certainly super out of style as far as UX choices go, but you know what? It is one line of JavaScript, or sorry, one function call, and it works. So for our purposes here, that's what we're going to use. Again, proof of concept. We don't need this to be fancy. We just need it to work. And maybe on Friday we can revisit and change up all this kind of stuff that I'm making shortcuts on here. But anyway, we're going to make a prompt. The question is going to be withdraw how much ETH. We're going to make sure that they know they should do it in ETH. And then we're going to say withdraw amount in ETH equals, like that. Because smart contracts are always operating with WEI and not with ETH, I always try to keep track in my variable names of what units I'm storing. And then the way I usually write these is I then do the Web3 call. So that's going to be we need to get our instance of our factory, or not our factory, but our subscription manager contract, which I think we put in here somewhere. Oh yeah, it's a computed value, SM contract interface, right? No, instance, SM contract instance, SM contract instance dot. Now we need the function name, and that's just withdraw. I think that's all it's called. Let's just double check on what we called it in Solidity. Withdraw. Yep. Okay. And this is going to take one argument. Oh, and this actually needs to be window.app. There we go, because we're pulling it out of this this view app here. And I'm going to start referencing this function down here because these are very similar. They're both just calling a contract function, and both of them need to pass arguments. And in this case, our only argument is the amount. So I'm going to say withdraw amount in WEI, which you'll notice I have not defined yet. We'll get to that in a second. And just like in this function down here, I'm going to pass the transaction object, which is also not defined yet. And then function, this is the callback. And so that one intermediary step we got to do is we got to say withdraw amount in WEI equals web3.toWEI. Put in our withdraw amount in ETH, and we tell it we're coming from the unit Ether. Okay, that should all work fine. And now all we want to do is, I suppose, exactly the same thing as this. Check for an error, log it if there is an error. If there's not an error, append the transaction to our transactions list in our app. And we want to give it a different label here. Withdraw transaction. And actually, that should be pretty much it. Yeah, that's right. Sayron has it right. Don't try to be shiny. Try to be useful, and that is especially important in today's, the industry of ICOs and smart contract development today. There's a lot out there that's shiny, and it's better to be useful, especially in these bubbly times. So, okay, save that. Let's see if our withdraw function works. Of course, we'll have to make sure that there's Ether in it first. I am going to go here and refresh. Now, I'm going to be right back, guys. Give me just 2 minutes. All right, I am back. Nothing on the Slack, looks like. Okay. Yeah, let's test this out. Let's go and grab contract address, slap it in there, and okay, before I click withdraw, I'm going to take this address, go to Etherscan and see what the balance of this actually is. Well, there shouldn't be anything on it because we just created this today. So before doing anything, I'm just going to send some Ether to here. And again, I noted this, I think, when we were creating the contract on Monday, but this contract doesn't limit anyone from depositing money into it. And we could have done that. If we go look at this fallback function, we make it payable. We could have had, we have our modifier here of only owner, right? Which prevents anyone except for the owner to do anything, or whatever you apply the modifier to. We could have put the modifier here just like this. Could have just said only owner, and that would have prevented anyone from depositing into this except for the owner. But as I said last Monday, there's not really much reason to do that, and even the owner, which is really the primary customer, the primary user of this contract, even the owner would appreciate if anybody can deposit into this. It's hard to imagine a case where they wouldn't want somebody to deposit into this. So anyway, let's get back to our Ropsten. So we just want to send to this address. So I'm just going to copy this, go to my MetaMask, and so you'll see I can deposit into this contract even though we don't have a deposit button there. But the reason I still want to make one is because this step that I'm about to do, where I go to MetaMask, I click send, I have to copy and paste like that. That's 2 or 3 clicks or whatever. We can sort of skip all that with a deposit button, and it won't even be that complicated to put in. Maybe not strictly a proof of concept. Maybe this is inching more towards the minimum viable product, but it'll be so effortless to put in. So we're going to do it. Anyway, okay, let's put in 0.1 Ether in here. Again, this is all on Ropsten, so it doesn't really matter how much it's worth as long as I have the Ropsten Ether in my account. Okay, that's submitted. Let's wait for this to go through. Man, Ropsten is really fast. That's pretty cool. It didn't used to be like that. They must have changed something. Maybe there's some sort of nonprofit. I mean, there's got to be miners somewhere actually mining these transactions. Maybe they just decreased the difficulty a lot. Okay, cool. So that got in there. Now if we go back and look at our address and refresh, or sorry, our contract. We should see the ether in there. Cool. So I'm going to click the withdraw button in a second. Yeah, you could. That's true. Yeah, you could use it as a budgeting tool. You could put, say, $200 in there, and know that you can only pull from it. Yeah, that's right. You could even have the owner of the contract set to a multi-sig between you and whoever's paying you, and that way you and the owner, or sorry, you and the payer can negotiate to change the rate at which you can pull from the contract, and that way it would be sort of a way that the payer, or sorry, the employer, whoever's giving you money, could just throw the lump sum away and sort of forget about it, but at the same time know that you can only take out so much at once. Yeah, well, maybe there could be lots of uses to this. Okay, so we have the one ether in there. Now let's go to our interface, and another thing we could add in here is to show the address, or show the balance of this. That's actually a pretty essential thing. I'm going to go ahead and put that in our bonus objectives here, and that's what this should be, bonus objectives. And that is to display balance of SM contract, because I don't think we have that here. We had it on our deposit interface, which this one was made from, but we don't have it here. So that shouldn't be hard to put in. But anyway, that's not our main objective. Our main objective is to what is our main objective? I'm kind of actually losing track here. Oh yeah, deposit and withdraw. That's what we're doing, and we need to test this withdraw button. So first, I want to make sure I am the owner, which should be my main. Yep, I am. And so let's see. I'm gonna. What happens here? Did I refresh already? Yes, I did. Okay. Well, the prompt is working. So there's 0.1 ether in there. So I suppose I'm just going to try to withdraw all of it, because that should work just fine. And now MetaMask should pop up, but it doesn't. So let's see. It's probably an error. Oh, a transaction object is not defined. Yeah, I forgot to do that. Let's get back in here. That's pretty simple fix. In fact, I'm just going to copy this straight up. And I'll just talk again about these values in here. There's gas and there's gas price. You know, I try not to get too upset at the Web3.js guys, because they made the first version of whatever this is, but this should really be called gas limit, and it's not. It's called gas, which is a little misleading because there's really two gas variables here. So anyway, this number is the gas limit. This represents how much execution you're going to let the contract do before sort of giving up. And there is a maximum to this number. I don't know what it is, but if I add a couple more zeros here, which I'm just going to undo that, but if I add just a couple too many zeros here, I'll run into the limit on Ethereum, where a contract call has a global maximum of gas that it will never go over. And so that's your hard limit on things if you try to iterate through too many items on a list or whatever. But in any case, this 600,000 is just, I don't know, it's a number that works for me. And another thing to note about this is that it's the gas limit. So if you make a call and it doesn't go through all this gas, you don't get charged for 600,000 units of gas. You only get charged for what it's used. So you kind of want to overshoot this, and that won't bite you as long as your contract doesn't have any bugs. The only time that this might charge you more is if there's an unexpected bug in the contract and you've put this number very high, and it gets caught in an infinite loop or something, and then it'll spend all your gas. And in that case, it might have been better to have a smaller value. But you know, I think that it's better to design a contract that's so simple that you're barely running into those bugs, or when you run into it once, you fix it. So that's the gas limit. You know, how much execution do you want to let your contract do? And then again, this second one is the gas price. That's a lot like the transaction price in anything. So in Bitcoin, you know, the higher you put this, the quicker it's going to get mined. I could put 1 here, And I could probably put anything in here except for 0, and it's Ropsten, so it'll get mined. But when we go to mainnet, 10 I think is a good number. Sometimes when the network is really busy, it won't get included right away. Maybe it'll take a minute or two. If you really want to make absolutely sure it will always be included, I would say put in 20. But of course, even then, I don't know, maybe in a few months here, Ethereum will always be at capacity. Then maybe you'll have to go to 30 or 80 or whatever, and we'll just see how that market develops. I mean, we will get there eventually. I have no doubt that we'll get to the point where we're starting to have to increase this number if we want to see our transactions included with any speed. And then, of course, as the scaling solutions, that'll go back down. But so I guess long story short there is that this number is something you always got to be a little bit aware about because network congestion could blow up at any time, and we might eventually see the end of the days where it's ever not congested. It might just always be a little bit congested. Anyway, so that's all that again. Let's save and come back here and refresh. Put in my address again. Sorry, not my address, the contract address. And try to withdraw. And again, 0.1 Ether. Click OK. All right, MetaMask pops up. That's great. And once again, we can click here and see those limits pass through here. So that's what that transaction object helps us do. And again, the user can change any of this, which is nice. It's not set in stone, at least with MetaMask. Okay, confirm. Oh, and you can see what the fee would be here. But that's assuming that it uses up all the gas. Usually when you send these, as I said, it won't use up all the entire gas limit, so this will actually be a smaller number, but you can get the idea of the magnitude that you're looking at. And again, it's Ropsten, so that actually doesn't cost me anything, but on the main net, that would be the ballpark, perhaps, of what it would cost. Okay, so that all seemed to happen without any error. Let's go to MetaMask and click on that transaction and see as it mines here. We can see that it even knows, Etherscan knows what the function name is. Sometimes that'll happen. I don't really know how that works because Etherscan does not have my ABI. So I don't know how Etherscan knows that it's called withdraw. It's a little spooky. I think it has something to do with, I believe that when you call a function, you somehow hash the name or something. I don't know, but it's something I still haven't figured out. But this looks good. And we can even see it's transferred 1 Ether from this to that. And that's, I'm sure that's me. Let's just double check. Yeah, 0x XC835 XC8, that looks good. Yeah, that looks great. Looks like it happened just like we wanted it to. Let's go back to our contract. We'll see that the balance is 0. We can see that last transaction there. So I'd say that's a good enough test of the withdraw function. I mean, I could try it again and withdraw with less than the balance, but there's no reason to suspect that won't work. I mean, if you look at the code of what we're executing here, there's not even anything in our code about handling money. Or no, wait, so, no, there is. Hold up, I'm in the wrong one. The code to handle the money is literally 1 line. And I guess we could do another test just to make sure this requires doing what we want. For example, if I had this backward, that would be, that could maybe mess us up. But I'm going to keep going in the interest of time. You might want to test this more. Certainly, I guess the reason I'm not too crazy, not too worried about testing every single thing in here, even though it's a smart contract, even though we're trying to make something immortal and doesn't have any bugs, is that we're just rushing again towards the proof of concept, and there will come a point where we want to publicize this and tell people to start using it, and at that point, that is when our to-do list will have an item on there that says test everything, and then we'll go and we'll really test the shit out of it as much as we can. Maybe even get some automated tests in there, although I don't use automated tests often. But in any case, we have that chance later. And since this is just something we're working on among us, we don't need to really be too stringent. I mean, there's no real money in here. As long as we remember to do it later. We have to test the shit out of it later. Anyway, a final thing to note. Oh, I got another something. I don't think withdraw was pulled from the event emitted. And I was actually just going to talk about the event that was emitted. Where was it? Where did our... Here, this is where... Let's get back to this last transaction. So this is what we were looking at. No. Oh, see, the binary data that formed the input of the transaction. So I guess that's a little bit of a hint there. But if we go to the event log here, which Etherscan shows us, it doesn't even know how to read this topic here. And I believe also we capitalized the event differently anyway. So our withdraw is a capital W here. And what it's calling our function here, where was I? Right here, it's not capital. Also, it has the, does it have the name of the argument? Withdraw amount. That's interesting. That so I don't know where that value term comes from. In any case, that's a bit of a tangent, but I don't think it comes from the event. And this happens, as I recall, even when there are no events or when there's multiple events. And as this indicates, Etherscan does not know how to read the events. Anyway, okay. That's enough of that. Let's close that. So I guess I can go back to my outline and cross this off. Oh, well, we don't have the deposit button yet. So let's do that. I'm going to close some of this. I guess I'll just close all of this. I'll keep my crypto open and close that. All right. Let's now, okay, what do we, I don't need this in my face. We'll work on this. We want to do the deposit button. So the deposit is going to, well, it's going to start the same. Whoops, I keep clicking that instead of my text. We already have the button. Let's go get the name of the function that the button is calling. And maybe I could just call this trigger deposit. I suppose that's fine. Yeah, let's just do that. It's clear. Okay. Trigger deposit. I somehow want to put that actually above the withdraw function, which actually makes sense because it's above the withdraw function in our interface as well. Right? Yeah, deposit. So I like to be consistent. Okay, so the prompt and the conversion is going to be exactly the same, except we can change some of the words here. Deposit how much, and then let's change deposit amount in ETH. Deposit amount. Oh wait, I want to Control Z. I want to show you guys something that's really cool about this text editor. This text editor is Atom. You can select text, and then you can hold Control and select different areas, and then you can actually type, and it'll type in all of those places. It's so fucking cool. Anyway, that's pretty cool. It's like a quicker, easier to use find and replace. And anyway, okay. So that is that. Now we need to actually do the deposit, and now here's where things will differ, because here we're calling a contract function, and here we're just going to send money to the contract. It's a different thing. We might be able to call the fallback function as a function, but I certainly don't know how, and I'm not going to worry about it because we can just send Ether. Although I'll have to, I suppose I have to go look at the docs to actually figure that out. I don't usually trigger MetaMask to send anywhere. Let's Web3.js old docs. I always have to find these old docs because MetaMask doesn't use Web3.js 1.0. It uses the what is it called here? Yeah, for 0.2x.x. It's a little frustrating. I'm just going to go on a tangent here. MetaMask Web3.js 1.0. You see this is an issue. It has been open for a long time. People keep saying that they're going to work on it. It says it's closed, but I think that's a little bit misleading. Last I checked, this was not. See, the first working draft. I don't think this is actually done yet, though. Line 113, the error message is still old from copy paste. 113. Ah, thank you. That's a good catch there, Sayron. Okay, yeah, that is something I've overlooked. Okay, so this needs to be withdraw like that. Thank you, Sayron. That's a great catch. That would have made for a very confusing debug session to get the wrong. It'd be telling you to look at the wrong place. Thank you so much for that. Okay, so back to here. Oh, that's right, we were looking up. Anyway, so that's frustrating, but what it means is that you got to look up the API for the 0.2x. But, okay, so let's go, and we need to look for send transaction. I believe that is what we want. ETH send transaction. Yeah, okay, so this doesn't look like it'll be that complex. We're going to make the transaction object again, and in this transaction object, we're actually going to specify the ether that we want to send. So, transaction object, I guess I'm calling it ticks object later, equals, okay. Now, I am not going to set the gas and the gas price because I believe that MetaMask is intelligent enough to since we're just sending ether, MetaMask should be intelligent enough to set the gas and the gas price correctly. So, but what I am going to put in here is, I think it's called value, to value, yes. Value, deposit amount in away, and then, okay, we also need to say we need to say where we're sending it, because we're not, all these calls we're using a contract interface, and that knows its address. Here we're going to be sending something without a contract interface, so we need to actually tell it the address we're going to send to, and that's pretty easy too. And then we put the address, which is, let's see here. It's going to be app.sm address input. Now, I should probably you know, if I'm going to be a perfect programmer, I would probably change this word now, because I'm using this. It's called input, but I'm using it as if it's a variable that is somehow more like I guess more, I don't know, more permanent than an input variable. So ideally I should change that name, maybe even make a couple different variables, but I'm not going to worry about that right now. That's probably good enough, and then we just need to send it, which is this call right here. ETH.send transaction and subject like that, and then we're going to do the function and result. Okay, and same thing. Let's copy and paste, and this time I am going to change the error message. Error depositing ether. Okay, cool. Save. Oh, and this should be changed. Deposit. Okay, let's save and go over to our interface and see if that works like it should. Refresh. Get our contract address and deposit. How much? How much do I have? I should just know anyway. 0.64. Let's put a 0.5. Let's put in a lot of fake ether. Okay, that looks good. Looks like it's including Ether. It's weird that it shows you the USD amount but not the Ether amount. And it's weird and it's stupid. I'm just going to go out there and say it. It's just stupid. It does show you down here, but that's the amount plus gas. Which I guess is close enough. But, oh, this is all zeros. This looks like it's saying 0. Let me look at this. Gas price is 0. Okay, so I bet now, I'm just going to see and click confirm, but I bet it'll give us an error. Yep, there's the error. So now I could manually get around this error if I go to deposit, and I'll say 0.5. And when MetaMask pops up, I can just change that here in the settings. I could say gas price is in gigawatt, so I'm just going to say 10. Come on now. What's going on? 10. Save, confirm, and now that will probably work. And indeed it did. See our deposit transaction pop out here. But it's certainly not user friendly. And so I thought I wouldn't have to set these defaults, but I probably should. So I'm going to go to, where are we? Transaction object here. And I guess I could make this more readable by putting it in multi-line. Value to gas, right? Gas price. Yeah, gas price. That's what we want to change. Okay, save, and let's refresh. Well, first let's see if that first deposit thing went through, because I was able to manually change it. So I should say the second deposit, the one that I manually changed. Go to MetaMask. It does say confirmed, and I don't have the money anymore. So it better be in the contract. I'm sure it is. Let's just go look though. There it is. Cool. So the deposit button worked a little bit, and now I'm just going to now refresh and make sure that it works without that little manual thing that I had to do last time. So contract, paste that. Click on deposit. Let's do just a little bit this time. Click OK. And we should be able to see a non-zero gas here. There it is. That looks great. Confirm. Cool. That all works. Okay, so we're almost an hour into the stream now, the seminar, and we have gotten 1, 2, and 3 done. Okay, so I am going to take a let's just do like a 5-minute break, 5 to 10 minute break. These are always going 2 hours, and I know 2 hours is a long time to sit here, so I think I'm going to do a break right there. I'll try to make that a regular thing, doing a break in the middle of these seminars, because they are long. So it's 18:58 now. I'm going to start up again at 19:05 on the dot. So that gives us about 7 minutes. I played some music for you guys, but I was told that that's a bad idea because people can like shut down my stream and shit if I play copyrighted music. So that's I'm not going to do that, I guess. I am going to turn off my mic, but yeah, I'll be back at 19:05. Okay, we are back. Make sure I got the mic setting correct here. Yeah, okay, cool. All right, so yeah, so next on our list is to we want to output information. We want to be able to output information on a given biller. Earlier in the seminar, we had to go to My Crypto to see the change we made when we put all this stuff in. And so the way that I am going to approach this is I'm actually going to sort of redesign this part of the interface here. I'm going to have this biller address at the top, and when you put it in, when you put the biller address in, it's going to automatically load the info for that biller, and then we'll still have a set permissions button, but it's going to be rearranged a little bit so that it'll be sort of next to the information that already gets pulled and displayed. So I guess I'm going to do the visual to redesign first. And when I say redesign, you know, don't expect anything too complicated here, but it's really just going to be visually separating things with some breaks. Set biller permit. Okay, I guess I'm also going to change the title here. Biller info, I suppose. I think that's what I'm going to do. Biller info. And then we can take out a biller because it's right under biller info. Address is enough. Put another break there, and then I'm going to have some outputs first. So I'm going to keep this stuff here, but I'm going to have it output first. So billing rate, and then here I'm just going to say, let's see, just trying to figure out, I guess, yeah, okay, billing rate output, like that. And then what else? There's also the last build time. Last build. Now, something we might get to, we might not get to, is to have this output a date and not a number. Certainly for this billing rate output, we can output that. We can just do the reverse of the math we've already done to output that in ETH per month, or even ETH per second, or something. ETH per 30 days, and we can do ETH per day. Well, we can do anything we want there, but anyway, I don't know if we'll be able to output this in a way that's easily human readable, but we'll at least be able to output it, if nothing else. Let's just see how that looks. Oh my goodness. Oh, I put a bunch of references in here to things that don't exist yet in the View app, so I'm just going to fix that right now. Another neat feature of this is you can split. How do you? I think you can split it. View panes. Yeah, this is cool. You can split it. So I'm going to go down here to where my new terms are and go up here now to my my app here. And don't forget the comma. And the other one's called last build output. I guess I'm just going to put a 0 for now, because we'll certainly be outputting it as a number first, and then later we might change it to some kind of date. Although, I guess instead of numbers, I'm just going to put loading, like that. Loading. Okay. All right, that's good. We can remove this split now. It is a pretty cool feature though, that's for sure. Okay, now with that fixed, we should be able to refresh and get rid of these ugly errors at least. Okay, that's good. Last build loading, billing rate loading. Okay. Does that look okay? This looks a bit weird. I want to sort of move this around. It'd be cool to have the button right under here. But then I would want the button to open up with its own form, and I'm hesitant to just do like 2 prompts right in a row. I mean, that'll work, but it's pretty fucking ho-dunk. Oh no, I guess you would only need 1 input, just the rate. You don't need to input anything about the last build time, so I guess that's what I'm going to do. I'm going to replace this input box with a prompt, and then replace this whole thing with just the button, and we'll probably rename the button too. So, and we might have to also change some of the functions depending on how I've written that. So let's see. I am going to, for now, I'm just going to comment this out, just in case something gets hairy and we want to go back to the way things were. And then I'm going to copy the button that we had, and I'm going to change the name here to change biller rate. That's what we really want to do. And call set bill rate. That seems fine still. And later we will put in a v show to make this only show up if the user is the owner, but we're not going to worry about that now. We're just going to worry about getting this working. Okay, that's good enough for changing the interface around. Let's just refresh and see how that looks. Yeah, I think that's fine. And now let's make these actually load something. So I'm going to do the same thing here as I did here, where oh, actually, you know, before I move on, I should just make this button functional, because this is not going to work right now because we took away that input field. So I'm gonna make that change first. This function is going to be looking for something that it can't find. Let's find it where we've defined it. There it is. Okay, I was looking right at it. You see, it just grabs it right from there. I guess this is well, no, that we want to keep the same, but here, this is what we want to change. This will actually be really easy. We just change this to prompt, and we decide what we want to ask, which is new billing rate per 30 days. There, that's really easy. Now let's just save, refresh, make sure that still works. Let's get my address of the contract, put it in here. Make sure I'm still the owner, signed in as the owner. Yep. And let's see, I need an address of the biller still, so I need to get Alice's address. Alice. Put it in here. Change biller rate. Let's set it to 0. Okay, everything still seems to be working. Confirm. And I mean, if that worked, the transaction should mine. If we haven't got an error by this point, I'd be really surprised that this would somehow be broken, but let's just watch just to be sure. I guess I'll just keep the tab up and I'll check back on it later. If I see a success, I might forget what I was checking, which that's fine. If there's an error, then I'll freak out and hunt the bug down, but I'm pretty sure that will go through. In fact, it might have already gone through. Robson is so fast. It's been included. Doesn't say whether it's successful or not, because transactions can be included and unsuccessful. Okay, keep that open. I don't need this open anymore. Okay, so back to now our main sort of mission right now. which is to what is it that we're trying to even do here? We're trying to get these to be loaded. Oh yeah, so what I was saying is that we already have it set up right now to where when we put in this address, it automatically loads everything. It automatically loads the contract. It'd be nice if when we put in this address here, it'll automatically load the billing rate and the last build time. Let's see about implementing that in the code here. The view framework has two approaches here. You can have something that's computed. That's how I implement the contract instance. Or you can have a watch, which means you give it a name of a variable. Whenever that variable changes, it does something. If we we want to sort of, if we want to do the computed thing, we would make this billing rate a computed entity. The problem with that is that we don't want this to always be computed. We don't want to try to compute the billing rate when there is no address, and when there's no biller address, or when there's no subscription manager contract address, because it would give us some error. We'd have some errors be running here. We don't really want that, so I'm going to do a watch instead, which makes things a little bit more explicit, a little bit more imperative as well. So anyway, to do a watch, then we start a watch by saying, okay, so here's one watch. We'll go here and comma. We're going to do another watch, and we're going to be watching this input here. And what is the name of that input? Don't remember for sure. This should be minimized. I don't need that huge thing. Input. Okay, biller address input. Okay, so this is the function that's now going to run every time biller address input changes. And we want to load, again, we want to load two things, the billing rate and the last build. And we're going to, so to get those, we need to use the SM contract interface. And I'm tempted to, well, I guess it's just going to be this simple. This is our code right here. I was going to sort of try to split this up into two functions, but our code is going to be pretty much just as simple as this. So we don't really need to, you know, fragment that any further, I don't think. So we want to go this.sm. We're still using the SM contract instance. And now we are going to be calling not owner, but we're going to be calling, let's go to Solidity, look at what our things are called here. Okay, so now this is going to get a little bit, got to think about this a little bit, because our public member of our contract is a mapping. And so here, when we just said owner and a function, I mean, that's simple, but we can't just say billers here, because we need to somehow pass to it which biller to specify. And I think that that's just going to be, we're going to pass it just like we pass an argument in our other Web3 contract calls. So we put in this first argument right here, the address of the biller. And that biller address is, of course, going to be biller address input, and it's going to be this.biller address input. And then we need a function callback. Like that. And once again, our this keyword will no longer work. It was pointed out in let's see, where was it? In Dev General. I need to clean up these channels, so I apologize for all these. Although some of these represent old projects that might be interesting to you guys. Anyway, Bo pointed out in here that if we use this notation up here, then that kind of fixes our this issues. and it's because I'm using this function syntax that this doesn't work. So that would be something to fix. I do sort of intend to fix that. I don't know if I'll find the time, and I don't want to sidetrack the stream and get into that now. So I'm just going to keep on using this function way of doing things, and instead of using this, the drawback of that is I just have to go window.app. Whatever it is that I'm looking for. But just know that this probably isn't the more elegant way of doing it up here, because then you can start using the this variable again, like you should be able to. Makes things a little clearer, but this works just fine for now. Okay, we need billing rate. What are we doing here? Man, after this long in a stream, I start to get a little harebrained here. Yeah, we're getting the biller. We've passed in the biller address input to get the specific biller, and now we're getting a result back. So this result should be a struct. And I guess I don't really know how to handle a struct as a return variable. So what I'm going to do is I'm just going to say console.log result, and then I'm just going to run this and inspect it in the console. So when we change the biller address input, we should see a log on the console that tells us what this result looks like, and maybe will hopefully tell us how to actually use it directly. So let's go here and reload all this, refresh I should say, get the contract address, plop her in, and now when I update this, we should see a log over here. So whoops, I need to go back here, and Alice is our biller. Paste it in. Okay, we have this little guy. We have a 0 and a 1. I think that is a big number. Whoa, let's not get into that. And this looks like a number. Array. Oh, here we go. It looks like our numbers are in these arrays right here. Okay, well, that looks like it won't be too hard. Before trying to just use that directly, I'm just going to see if there's, let's see, contract return struct. Let's just see what that, this looks juicy. This doesn't seem to be, this seems to be suggesting that I make returns Don't know if that's really what I want. Sometimes you look at these issues, you don't know if they've actually done it, or they're just talking about doing it. It doesn't say it's resolved and released. Only for automatic public accessors. Okay, that's fine. It's saying that it only works for automatic public accessors, which is what we have here. Where did it go? It's a public billers. It doesn't tell me how to actually do it. Well, I was hoping for some Web3 code. We might just have to get a little hacky here. So here we can see that the values, that's the 0. That certainly looks like the timestamp. I guess just to, whoops, whoa, let's get out of here. Just to double check, I can go look at that Unix timestamp again and verify that is unixtimestamp.com. Verify that that is actually a timestamp. 15307 whatever. And 15307. Okay, so that's definitely a timestamp. And that should be 0. So it looks like it's these R's. I wonder if I can let's see if we can okay, I'm just going to log the type. Another thing we can do, type of result. Save that, refresh everything, take the address, put it in, take Alice's address, put that in. It's an object. Okay, well, that's not very helpful. Okay, I'm losing my mind a little bit here. I guess I'm a little tired here. Okay, so I'm gonna log this again. I should have taken a screenshot or taken notes or something, and just use our debug output and see if we can just manually pick that out. So we have a list of 2 things. It's of 2 objects here, and each of these has an S, an E, and a C. And for each of these, C is an array of 1 length with our item in it. Okay. Let's. Whoops! I didn't want to do that. Close pane. Okay, so I'm going to make this a bit smaller like this and see about getting at those. Where are we? Let's see. Deposit call. Nope, nothing in there. Oh yeah, it's up in here in our app. Okay. So let's keep that line in, but let's actually try to do something with this now. So let's just see if we can get the rate. Equals, okay, we have result is a list of 2, so we're going to grab the first one, .c, 0. Let's just try to console log that. Instead of setting it, let's just see if that expression does what it looks like it should do. Okay, so here, refresh, get the contract again, put it in here, get Alice's address again, put it in here, 0. Okay, well that seems good. Okay. Probably should have tried it on the timestamp just to make sure. Well, I guess I can do that really easily, huh? Just change this to a 1. And actually, you know, I think the structure here, this C, I think, well, not the structure, this R, I think this whole R object is a big number. It's the big number type, and that Web3 uses, because JavaScript doesn't handle big numbers very well, so they actually have a specific big number type, and I bet you that's what these are. So let's save this, refresh, and make sure that works. Yep, those both seem to work. And just to see if we can simplify that code, if these are big numbers, then I wonder if we can actually just do that. I bet you we can. I bet I've just been overthinking this. I bet it's just that easy. Well, oh, I think I just pasted what I meant to copy. Let's cancel that. That would have been annoying. Now let's put her in. We get this, although that might. Sorry, this is taking a little while, guys. I've never actually done this before. I've never had to pull a struct from a contract interface. And it's not actually even really technically supported by Ethereum. Okay, so it looks like, yeah, that's what a big number looks like. That's what I was just testing. I logged a big number just to see if that's what it looks like. So it looks like result 1 and result 0 and result 1 are just big numbers. That is great news. Oh, okay, let's actually now do something with these. It's going to be pretty simple. I'm going to comment this out, but leave it in there. I guess I don't even really need to leave it in there. So we have a result 0 and a result 1. And we want to set billing rate, let's see, window.app.billing rate output equals result ooh, excuse me, result 0 window.app dot the other one is last build output equals res 1. Okay, that should work just fine. Let's make sure. Hey, that's pretty good, although there's these weird quote marks. That is weird. I wonder why there's quote marks getting in there. Well, these start out as strings, and they go in as big numbers. I wonder if I can do this. Okay, there we go. That looks like it works. And we can still change the biller rate if we're the owner. Anyone will see this button, but if you're not the owner, it will fail when it goes to the contract execution. So I guess let's look at the outline here. So we did the minor visual redesign. And we did all that. That all works. So I think we can cross off this whole thing. Before crossing it off, we should probably just test, just only because this is a 0. It'd be nice to set that to something else and actually verify that it changes. So let's go and change biller rate here. And we already have the biller address in there. And we should still be on my owner account. So I'm just going to make this just 1. Okay. Oh, you know what? This is going to give us the way per second value. So that is one more thing we'll need to change. But I'll confirm. Well, actually, we can still test that it does change from 0 before going into that change. I guess we should look at the watch, make sure it mines. There's that one. Oh, here's this other one we were going to watch, make sure it went through successfully, and it did. That's good. Close that. We can close that. Close that. And now we're just waiting on this guy to mine. Which will change the billing rate. Well, while we're waiting on that, I already know that even if this changes, it's going to give us the way per second value, and we don't want that. We want the ether per month value. Ether per 30 days value rather. So let's go to our code. And here we want to massage these results. So first thing I'm going to do is label these results. So first one is billing rate. So billing rate in way per second equals res 0. And last build timestamp equals res 1. Okay. Has this mined yet? It has. Let's refresh this. Actually, now we don't need to refresh because it's the contract that's changed and not our code here. So now, if I just cut and paste this, there we go. It'll refresh the value. And we could add a timer there to where it will refresh automatically in some sort of more polished interface. But that looks good. It changes to a non-zero value. Now we just need to make these a little bit more human readable. Now we do only have like 23 minutes left on the clock here. So rather than focus on making these readable, I guess I'm going to finish. I'm just going to finish this little change here, which doesn't change any of the functionality, but it makes things a little clearer. Later we can come in here and add in some conversions. We might even do that this stream, but first I want to go back to the outline and make sure there's nothing I want to get to first. Set billing rate is only visible to the owner. I added a button for the biller to use, like collect my bill. I would really like to get to number 6. And we have, as I said, 23 minutes left here. Because if we get number 6, even if we don't finish out 4 and 5, and 4 is pretty much done. I guess I could just add another one here that is not done, and that is make outputted values human readable. Right now they're not. So that's what we have left to do on 4. And then 5 is just going to make it's certainly not a proof of concept thing. It's just going to make the button disappear if you're not the owner. We can leave that in for now. So I think I will jump right to 6, and we'll work on 6. And if we get that done with time, we'll go back and try to hit these other ones and complete those. But number 6 is definitely going to get us closer to the proof of concept. So we want to add in a button for the biller to use. And when they click it, it calls our, it's going to call this remix function, or sorry, solidity function, call bill. And that should be very simple to do. So let's get cracking. Full screen this again. I guess let's put the button in first, as we've been doing. And so that we need to decide where we're going to put the button. What we're going to do. Subscription manager interaction, deposit withdraw, biller info. I guess I want to put it up here before biller info, because with this interface you need to specify a biller that you want to look up or change. And when we actually try to bill, we're not going to be specifying a biller. We'll just be using a given account as the biller. So I'm going to keep it separated from this stuff, and I want to put it up here somewhere in this section. So where do I want that button to be? I guess I could put it next to the withdraw, next to the deposit. I'll just put it under the withdraw for now. That would be fine. Okay, so let's find our withdraw button in the HTML. Change biller rate. No, we want withdraw. There's our withdraw button. So let's see, break, and do another break, and then button. Title of our button is going to be bill, and I should spell button correctly as well. That will help. And I'm going to say trigger bill. Somehow that seems to me to make it a little bit clearer that it'll happen automatically. Because when you click this, you won't need to put in any amount or anything. It'll just happen automatically. The contract will calculate how much it should give you, and just give you that. So since there's no other input there, I feel like trigger kind of indicates that you won't need to put anything else in. Anyway, on click, what's this function going to be called? Call bill, I guess. What is it called in our Solidity? I think it's actually called call bill in our Solidity. So yeah, it's a little silly, but if we want to keep our convention of call and then the Solidity name, we would have to call this call bill. That is a little silly, I gotta admit, but I'm just gonna leave it in there for now. We can figure that out later. Okay, let's save and make sure that looks okay on the interface here. I'm going to put in a deposit, or sorry, the contract address. Deposit, withdraw, trigger bill. Okay, that's good. Now let's put some functionality in there. Dang it. This is our function name, silly as it is. Okay, trigger withdraw, trigger deposit, call new. I guess I'm going to put it under the withdraw. Once again, keeping the ordering of these functions consistent with the actual layout of our page. Just makes things a little, just, you know, that few percent easier to understand, which is always good. Okay, so we don't need to prompt for any values. We really can just jump right into defining the transaction object and calling the function. And I'm just going to copy all of this. In fact, it might even be worth, something I could do is make a default transaction object that has this stuff in it. And then I could maybe copy that and add stuff to it when I actually use it. That might be something that worth doing, I mean, eventually. Okay, and then window.app.sn contract instance dot, and the name is call bill. That's the name of the contract function. Then we would put in any arguments. There are none. Then we put in the transaction object, and then we put in the callback. And we'll fucking hammer this out here really quick. Okay, and do very similar thing as to here. We'll handle the result a little differently though. Error calling bill. Error calling call bill. That's just silly. I'll have to rename some of that stuff. And then here, call bill transaction result. I guess that's all we need. Man, that's easy. It's going to be cool if that works, because that will have completed our interface, the proof of concept of our interface, and that was not very much code at all. Okay, so let's refresh. Once again, perhaps even for the last time. Well, no, because we still got those other stuff to go back and do, but I'll put that in there. And we'll put in, oh, we don't even need to put in Alice as the biller. So now, if I click trigger bill now, it will fail. Well, the MetaMask will pop up and I'll click confirm, but then the transaction itself will fail because I am not an approved biller. So I need to change to my Alice account. And now I need to refresh this and put that contract identifier in again. Okay, owner. And I could even, I'm just going to copy test Alice. And I can see, okay, that's the billing rate, and we can imagine that that is in some human readable form. But I recall I put that in 1 Ether a month. And let's see what the balance of this is. Oh, there might not, is there anything in it? Let's go look. That was to the contract here, so we can find it that way. Yeah, there's some Ether in there. A weird number of Ether in there. Oh, because we set the bill rate to 0, so I think it actually builds something already. One of these transactions, we set the bill rate, and within that function, if there's already a bill rate set, it sort of clears it out and sends the charge out to Alice. So that should have already happened, probably in the internal transactions. Yeah, there it is. That's probably Alice's address. So Alice already got a little bit of this subscription that she was approved for. That's pretty cool. But anyway, let's go back here, and we have Alice selected. We have the contract here. Let's trigger bill. Ooh. On click, call bill, reference error. Okay, my silly name is inconsistent. What did I call it? Oh, I called it the same thing. I must have copied from the wrong place. Call bill. Okay, try that again. Refresh. Get the contract. And trigger bill. MetaMask is coming up. That is a good sign. We got a non-zero gas fee. It's another good sign. Confirm. Okay, let's watch this now. There's our submitted transaction. This is going great. I shouldn't speak too soon though. I should wait until this goes through to say it's gone great. Okay, that's a success. And look at that, we have a transfer. That looks great. That's perfect. So this should be 1 ether divided by however much time it's been out of a month. In fact, I'm just going to do that math just to see it. Let's get the calculator up. Let's copy this. 1 ether divided by that number. Wait a minute, I did that wrong. I want to 1 ether times that number, I think. That should give us the amount of time, the fraction of a month it's been. So that's in 30 days. If we divide it by 30, that should give us the amount of days it's been. Wait, divide by 30 or multiply? I should have multiplied by 30. Okay, my math's getting a bit sloppy here, but okay, multiply by 30. Multiply by 24 will get us the number of hours, and multiply by 60 will get us the number of minutes. That seems about right. So there's 12 minutes between when the set bill rate was last called and when I clicked the bill. So you guys could even, as a fun bit of homework, go back in the video 12.28 minutes from when I triggered this, and you'll probably see me calling that last set bill rate to 1 ether. So that's pretty cool. I might even do that after I finish recording here. But that's great. That's super exciting. So let's go here and cross off. Nope, not that one. This one. All this can now be crossed off. Very cool. Okay, so we got 11 minutes left, and we have 2 choices on what to work on now. We could make the outputted values human readable, and we could make sure the set billing rate part of the interface is only visible. Okay, I'm going to do number 5 because that's going to be way simple. Number 3, there's 2 parts to number 3. If we wanted to do it, we'd have to, okay, let me get Alice's address just to demonstrate again. Setting the billing rate, translating that to a better number would be easy. We've done that a couple times back and forth. But this last build, we'd need to output it into a date. That's going to involve, at the very least, looking up a new JavaScript function and possibly getting some kind of library. I am not going to worry about that right now. And instead, I'm going to go and do, what was it, item number 5 here. which is just make this button to set the billing rate. We're going to make that disappear if the user is not the owner of the subscription manager contract. So let's go to Adam, and I'm going to add another variable way up here. I'm going to make it's a computed variable, so I'm going to add it here. User is owner. This is going to be a Boolean, and it's just going to represent whether the user is the owner. And the way that we can compute that is, let's see here. We need to get the owner. Window to app. We already have the SM owner here. Okay, that's right. And so now we need to check the MetaMask's accounts, which I believe you can get by just doing web3.eth.accounts0. And so now we just need to return a Boolean of whether that equals this.sm owner. And then so that should be fine. And then we need to go down here. And for everything that we want to hide, which is just the button, where is there? This button. So we're going to say v show equals, and then we tell it when to show it. So we want this to show when the user is owner. I believe that's all we need. I don't think we need to say app dot or window.app dot. I think it will check its own variables. But you know what? Let's just add that in because I think that'll work too. And it's a little bit more explicit. Okay, yeah, let's see if that works. So now I've saved. If I refresh this, whoa. Okay, it's saying cannot read property app of undefined. I think I was going a little too go-go. I think I need to not have that there. Let's try again. Yes, indeed. Okay, and you can see that that button is now gone. And if I change now to main, it should pop right back up. Nope. Maybe if I refresh. Oh, I need to load the contract first. Okay. So let's get the contract address here. And paste it. Okay, change biller rate is there, which makes sense because we are the owner. And let's change to Alice. It's still there. I would have expected that to just go away, but let's at least see if it still appears if we refresh and put in our contract address. Okay, well at least it does not appear in the first place if you load MetaMask with Alice, and I suspect that's because our list here that we pulled. Let's see. If we go back up to how it computes that user as owner, this accounts 0. That might not change when you reload a page, or maybe Vue doesn't know how to notice the change. In any case, we have it sort of working where if you go to this web page as the owner, you'll see that button pop up. And if you go to this web page as someone else, you won't see it pop up. So that's kind of cool. Let's cross that off here. Like that. And this last item here, I mean, if anybody that's watching this wants to do this, I mean, it would be, it's not really directly related to Web3 stuff, but it would give you just a little bit of experience editing these files. I would recommend, if you want to do that, I mean, just forking the GitHub, or I guess you don't need to fork it. You could just clone it and create a branch. In any case, you get the code, change it to make those outputted values human readable. You can even use, if you want to learn more about Vue or get some practice with Vue, this is a great opportunity for something called a Vue component. Maybe, I mean, unless there's a library that does it really really well, it being outputting a date from a timestamp. In fact, there's probably a really simple JavaScript way to do it. I have 5 minutes left. I guess I could just pump that out. All right, let's just see if we can do it. So let's go back to our code here. Surely we can do it. Okay, where? I just need to put some more lines in here. Let's see. I think, did I already do this somewhere else? I think I had somewhere like 3 lines, and it was the opposite. I go the opposite direction here, so I'm just going to rewrite it. I'm not going to try to copy paste. ETH. Oh wait, is it? Let's look again. ETH per. Yeah, we start with wait per second. And this one was okay. Yeah, it's the reverse. So I'm not going to copy paste. I'm just going to do it by hand here. ETH per second equals 3 dot from way per second. Ether. Okay. Billing rate in ETH per month equals okay, now we need to do our math here. Okay, if it's per month, we have so much per month, that's gonna, we have to divide that to get the day amount. Okay, so divided by, and we're gonna put a big number in here. That'll bring it down to days. That'll bring it down to hours. That'll bring it down to minutes. Wait a minute. No. I have the amount of seconds. I need to multiply that by a big number to get the amount per month. Okay, so that'll bring it from seconds. Okay, so let's redo all this. From seconds here, that'll get us the amount of minutes. That'll get us the amount of hours. That'll get us the amount of days. And that'll get us the amount of per 30 days. Yeah, that looks good. And then we just need to put this in here. Let's save that and just see if that bit works. We're gonna refresh. Take the contract address, come on. Take Alice's address as the biller. Okay, the billing rate shows up as almost 1 Ether per month, so that's a bit weird. It's close enough for me. I'm gonna not fuss with that. And then last build, we want to. Oh, you know what? I do have a meeting right at 20. So I'm going to stop there. I believe this might be really simple. There's probably just, I'm just going to do the Google real quick. I won't implement it, but JavaScript, Unix, timestamp to date. Look at that. Okay, so it is a few lines. Anyway, that is how you would do it. I'm going to stop there and call that good. We really got a lot done here. We have a full interface here to this subscription manager contract. Now, there's some other stuff you could do. You could look at the factory contract and then go find all of the subscription manager contracts that anyone has ever made. And then you could use that, for example, to look for everything from which you have permissions to bill from. That might be good if you're a biller. You have lots of different customers with lots of different subscription managers. But at least for the user and for a biller who wants to manually use this to bill a user, this works. This is completely functional. And later today, I will even post this on a GitHub pages. I'll make sure this is public so that you guys can use this. And I mean, hell, you could, in fact, you could even put it on mainnet if you really wanted to. Although I would test it a little bit before putting your real money on it, but certainly feel free. But yeah, I'm going to end it there. And then, so tomorrow is David's seminar, and he's going to go over using Go Ethereum with the Ethereum blockchain and with smart contracts. And we might even be able to work in something to where he can actually interact with the subscription manager stuff. That would be pretty cool. And then on Friday, we'll come back to this completed dApp here, and we're just going to sort of polish the interface. We might make some changes to the contract code, maybe change some names around, but just move towards finalization. We've definitely achieved the proof of concept, and now we can start moving on to a minimum viable product, which has a little bit more emphasis on usability and sort of like an intuitive interface. All right, guys, thanks for joining in, and I'll see you next time.